This is for Year 12 Further Maths. We're going to re-explain exercise 2G and how it applies to questions. So I said in class, in real life, when we measure something, so like hand or feet size or something like that, um, we get a distribution of different, let's say, measurements. Okay, so in class, we said that the height of female students might be 165 on average as the mean value. Okay, so as the most common. Now, the further away I move from this value, the less common it becomes. So 170 might be over here, and 160 might be over here. And what's even more uncommon might be 180, because there's less girls that are 180, and it will be 150 over here. Okay, and obviously very uncommon might be 190. Okay, and 140. Now this distribution is known as normal, a normal distribution, or known as a bell curve. Now, how do I measure how common something is? So the way we measure it is by something called standard deviation. So here we have the mean value, which is the most common value of the distribution. So most people will be within this mean region. Okay, so and if I'm one standard deviation away, or within one standard deviation, would say that's pretty common. That's 68% of the data, okay, or 34% each. If I move another standard deviation away, I'm 13.5%, okay, 13.5%. But as you can see, as you go further left or further right, the area gets more and smaller and smaller, okay, because whatever the measurement is, or whatever we're measuring, it lies quite away from the mean, okay. So this will be I think it's 2.35%, and this is 0.15%, okay? 2.35 and 0.15%. So this is what this is all about, basically, okay? You've got the corresponding, you've got the mean, and this is one standard deviation to the right, two standard deviations from the right, and three standard deviations from the right. This is one standard deviation to the left, two, three from the left, okay? So within one standard deviation from the mean on either side is 68% of the data. Two standard deviations, 95, and three standard deviations, 99.7%. So let's do a question. The blood pressure reading for executives is approximately normal distributed. So whenever it says that, you automatically go, I need to use a bell curve. It has a mean blood pressure of 134 and a standard deviation of 20. So what I always like to do is, I obviously have this chart with me. Okay, so on your cheat sheet, make sure you have that. But I also like to draw my own bell curve with the values given. Okay, so my mean is 134. Now, if I'm one standard deviation away from the mean to the right, then I just add 20. So this is 154. If I add one more standard deviation, I'm 174. Okay, if I add one more standard deviation, I'm 194. Let's go backwards. So if I subtract one standard deviation from the mean, so moving one to the left, I get 114. One more, I get 94. Another one more, I get 74. Okay, so it's really important that you draw this so you can answer the question. So approximately 68% of the executives have blood pressures between. Well, if you look at this graph, 68% lies between the first two, well, within one standard deviation of the mean on either side. Okay, that corresponds to 114 over here and 154. So 114 and 154. 95% of them lie between what? So if you look at 95%, it's two standard deviations on either side from the mean. Okay, because if you add this area here, you get 95%. So two standard deviations, just count 1, 2. So between 94 and from mean 1, 2, 174. 99.7%, that's three standard deviations. So if I go from here to there, That's three standard deviations, it's 95%. So 1, 2, 3, 74, 1, 2, 3, 74 to 194. Okay, it will lie between these data points. Okay. 16% will lie above. Okay, above what? Now, what value do we lie above to get that 16%? Okay, it can't be above the mean value. It can't be above 134 because that's half the data already. Okay, so that's not true. If I'm above one centimeter to the right, that's 154. Okay, so if I'm above 154 for our data, so right here, if I add 13.5, 2.35, and 0.15, I should get 16%. Okay, so that adds up to 16% of the data. So this would be above 154 in blood pressure. 2.5% will be below. Okay, below is going backwards. So if I go below, again, it's not going to be below this mark because this is the halfway mark. It won't be below this mark because this adds up to 16%. So it must be below this mark, which is 2 standard deviations to the left. So if I add these two together, I should get 2.5%. Okay, so it's below 2 standard deviations. We're going to look back at our chart. 1, 2, that's a blood pressure of 94. So it has to be below 94 to get to for for the number of people or the percentage of people that will have blood pressures below 94. About 0.15 have blood pressures below, okay, 0.15. We just go one standard deviation lower, so that's 0.15 there. So this would be 74. Okay, so it's 3 standard deviations. I count 1, 2, 3. Hang on, give me a second. Lost track. 1, 2, 3. Okay, yeah. So 1, 2, 3. It's meant to be below 74, which is great. About 50% of the executives have blood pressure above. Well, pretty straightforward. Above 50%. Well, we know the 50% mark is there. So above 50% will be whatever that value is. So 134. Okay. We will go over the next question. I'll just go over question 2. So this is a new question. They've given you the mean and the standard deviation. So you just got to draw the bell curve. Okay, so the mean value would be, they've given it to you, 1.88 kilograms, and the standard deviation is 0.2. So this will be, you can use a calculator for this. I'm not expecting you to do this in your head. 1.88 plus 0.2 would be 2.08, plus 0.2 would be 2.28, plus 0.2 would be 2.48. You go back down 1 point, if I subtract the standard deviation, I get 1.68, 1.48, 1.28. And so 1, 2, 3, 1, 2, 3. Okay, that should be enough. So what do we want? We want it between 168 and 208, 168 and 208. Okay, so they want the area here. Okay, so the area here corresponds to this between here and here. So that's what percentage of the data is that? That's 68% of the data. So 34 plus 34. Okay, second question. 128 and 248. 128 and 248. So they want the area here, 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 here. Oops, should draw the bubble again. Okay, so what do I need to add? That's 3 standard deviations on both sides. Okay, so we know that 3 standard deviations on both sides is 99.7%. 99.7%. 2.08 is approximately what percentage? More than 2.08. 2.08 happens to lie 1 standard deviation from the mean, so it's here. We want more than that, so that's the area we want to add. So that should get, if you add 30.5 plus 2.35 plus 0.15, you should get 16%. More than 2.28, more than 2.28 would be this area and that area, so that adds up to 2.5%. Less than 1.28, 1.28 happens to lie first standard deviation, So less than that would be this area. So that would be 0.15. And more than 1.88, more than 1.88 is, okay, well, 1.88 happens to be the mean value. So more than that would be 50% of the time. So that's 50%. Okay, so hopefully that gives you like an overview of how to approach a question like this.